It sometimes happens that one can find that you have just the right uh, ratio of the slit width to the distance between slits and double slit diffraction that you'll have missing orders. And so let's take a look at that real quickly. Just to recall, we found for a double slit with slit separation A and a slit width B that we got this for the intensity at the detector, sine beta over beta squared. That's due to the slit width. And then the cosine squared alpha, which is characteristic of just a point source of at the two slits. And remember here, alpha is Ka over 2 sine theta, and beta is Kb over 2 sine theta. We went into some detail deriving that formula last time. Well, this is just to point out that it's possible to have the following situation. For instance, let's suppose I plot this cosine squared alpha versus angle here, and one gets this cosine squared term, which looks something like this. So that's the cosine squared alpha term. And on top of that is this sort of modulated amplitude, if you will. And that's this beta. It's really the typical single slit diffraction. And let's suppose its B is just such that this dash line, remember this is way out of scale because this height is only about 4% of the height at the origin, but just to give you some idea. And what happens is that just as this sine beta over beta term reaches a minimum, well, that happens to also be the maximum of the cosine squared term. And so since this is a modulated amplitude, and the product of those two will be 0. And so what you get in these situations is something like this. You get this. This one is going to be decreased because of the amplitude. It's really this envelope. And then here it is, there's no there's where there should be a relative maximum, there's nothing. It's just flat. So we've got a missing order at this point. And then this next one goes up to like 4% of the original. So this is a little more in tune, but not, still out of scale. But now this one, it's reduced amplitude, and then this one is even further reduced, and then you might have another missing one out someplace further. But in any event, we've got a missing order at this point. And you know that the minima in either case is I should say the missing for such a missing order, we have this condition that sine theta m lambda. Remember that was our lambda portion for the maximum, and the minimum, if you go back and look, was this for the single for the slit diffraction by single slit. We have this, and I can get things to conspire just so that at the same angle theta here, I get a maximum for one and a minimum for the other one. And in that case, we can take the ratio, these two equations hold, we can take the ratio of these and get this A to B ratio. The sine theta will go out because I'm at the same angle here, and the same light is being used as m over n, where these are the usual integer values that they take. And so the condition really for a missing order is that A is equal to m over n times B. And when that condition is met, then somewhere down here you're going to have just the right conditions so that the zero of the envelope function of this one here occurs right where this one's a maximum. And when that happens, this should have been a relative maximum here. disappears, and so it's missing. And the condition can be found from that equation.